All right, good morning, good afternoon, good evening. Whenever you are listening to this video, it is the perfect time. So, right now I'm going to go over the concept of expanding polynomials by using the binomial theorem. And you can do this one or two ways. You can do this by using the binomial theorem, which is connected to um, just expanding it through Pascal, or you can just multiply it out, right? So, Pascal's triangle, we go says like this. So today we're going to end up doing four iterations. We're going to expand it to the fourth power. So right here with the Pascal's triangle, anytime you get a space in between, you want to add those two numbers on the edge. So 1 and 1 gives us 2, but you always start with a 1 on the outside. So 2 and 1 gives us 3, 3, 1, 1, 3 plus 1 gives us 4, 3 plus 3 gives us 6, 3 plus 1 gives us 4, and then 1. Right, so we have our tree. So I said we're going to go to the fourth iteration. So these are the numbers that we have set. So we're going to have P0, P1, P2, P3, and P4. Again, I'm going to preface this by saying you can do this by multiplying it out by using the FOIL method. I find that this method is a little bit more accurate and a little bit more easier, even though it is highly detailed. All right, so let's get to it. All right, so now we're going to do 1 plus 4i to the fourth power, and we're going to expand that by using a binomial theorem. And so first thing we want to identify what our a is. Our a is 1. We want to identify where our b is. Our b in this instance is 4i. We want to identify where our n is. N here will be 4. Right. So now we want to label what our P0 through P4 is. So we know that's 1, P1 is 4, P2 is 6, P3 is 4, P4 is 1. So when we start to do our iterations and we start multiplying, this is going to be extremely important, right? So all the binomial theorem is a summation, meaning it's a series of numbers or series of expressions, and you're adding them together, starting from 0 to 4. So that's where we get P0, P1, P2, P3, P4 from, because it's a summation, meaning we're going to add from the 0th iteration to the 4th iteration. We're going to add all of those up together. And so what we end up having is we have an equation or a summation that looks like this. P0, A to the 4, B to the 0, right? I put B to the 0 because we want to be able to see the numbers increase with our B's and decrease with our A's so we can understand the pattern. But anything raised to the 0 power is 1. So let me go ahead and finish this up. Now we have our total summation from P0 to P4. Now we can start substituting in what those numbers are, right? So P0 in this instance will be 1. A is 1, so that's 1 to the fourth power. And then you have 4i to the 0. Again, anything raised to the 0 power would be equal to 1. So here's what we have. We have 1 times 1 to the fourth power times 4i to the 0. And as you can see, our P summations are in the order that we said they were, right? And so now we got to go ahead and do the mathematics on this. We know that 4i to the 0 is just 1. So that means for our first one, 1 to the fourth power will just be 1. And so I'm going to reserve putting in the pluses and the minus right away because we don't know if the I being squared or cubed or to the fourth power is going to give us a positive or a negative number. So in this instance here, we have 4 times 1, which is still 4. And then 4 times 4i will give us plus 16i, right? Now here we have 6, 1 squared, 4i squared. Now remember, when you have 4i squared or a number I squared, you also have to square the number. So here, 4 squared will give us 16. 16 times 6 will give us 96. I squared is equal to -1. So that means here we have -96, right? Same thing here. We got 4 again. So 4 times 4 cubed. 4 cubed times 4 will give us 256. I cubed is a negative I. So that means we have -256I. And last but not least, we have 4 raised to the 4th power, I raised to the 4th power. That's going to give us positive 256 because I to the 4th power is positive 1. Right? So when we combine like terms, you combine the 1, the -96, and the positive 256, you're going to end up with 161. And you combine the 16i with the -256, you're going to end up with a -240i. Right? So this is how you do this one, and this is this answer. Now again, like I said, this is detailed. It takes a little bit of time, but it will take a little bit longer if you multiply all of this all the way out 4 times and FOILed it. So this is that process, right? All right, so now we're going to do a whole different problem. Still going to be to the 4th power or the 4th iteration because I want to keep the same system, right? So we still have the same summation 14641 from Pascal's theorem. Now we just have to start off by identifying our new A and our new B. So our new A will be 2 and our new B will be 5 to the I, right? And so now let's go ahead and write out our summation. All right, so now we have our summation set and we have our summation written there correctly. Now we go ahead and start our substitution. All right, so now we have our summation written out. We have substituted it correctly. Now we can go ahead and simplify, right? So here we have 1 times 2 to the 4th, which will give us 16. 5i to the 0 power will just give us 1, so this part is just 16. Again, like I said, I'm going to reserve the right to write our pluses and minuses for our numbers until we figure out the sign. So 4 times 2 cubed, 2 cubed is 8. So 4 times 8 times 5 will give us 160. I is to the 1 power, so we know it stays as I. So we have a positive 160I. 160I here. Now we have 2 squared, 5 squared. So 6 times 4 times 25 will give us 600. I squared will give us a -1, so that'll make this a -600. 4 times 2 will give us 8. 8 times 125 will give us 1,000. I to the cube will give us a negative I. So that's -1,000I. Then last but not least, we have 5 to the 4th power, 625. I to the 4th power is +1. So now we have plus 625. And again, like I said, the more you do these, as you do a couple of them, it'll kind of start to seep in and make sense and it'll become easier. Again, it's a little bit more detailed, but this is the easiest and fastest way to get this done. So again, like last time, we want to combine like terms. So here we have our like terms. We know that 600 and 620, -600 and 625 gives us 25. 25 and 16 will give us a positive 41. Positive 160i, -1,000i will give us -841i. And here's how you expand with the binomial theorem. I hope this helps. If you guys got any questions, please don't hesitate to let me know.